This presentation is a demonstration on how relatively accessible tools can be used to produce LiDAR-based scan maps, as well as how they can be manipulated and used in a construction context. So before we begin, I just want to clarify that the LiDAR scanner feature on Apple devices is a Pro model feature that is exclusive to the iPhone 12 and later, as well as the iPad second generation and later. The app that I'll be using for this demonstration is going to be called Canvas. There is not currently a native Apple software that allows you to take LiDAR scans. However, there are alternatives such as Polycam and Scandy that are available on the App Store. I just chose to use Canvas because most of the required features are not paid. So the first thing you'll see when you open up the app is a project screen just like this. You're going to start by pressing on Add Project on the bottom right corner. Pressing that is going to bring up a prompt between scans and plans. What you're going to want to press on is scans, which is going to bring up another prompt to name your project. And then on the top right corner, you're going to want to press create. This is going to allow you to actually begin the LiDAR scanning process. So as you can see, I've got my friend here recording an outside perspective while I record the inside perspective of the scanning process, just so you guys can get a better understanding of how the process actually kind of looks. So as you can see on screen, the app actually provides you a simulated coverage of what you've already scanned, which you can see is being highlighted by these grayed out areas here. Now you want to give the LiDAR scanner as much context to work with as possible because it's going to affect the end result of the scan when you import it as a 3D mesh object. So here you can see I'm trying to get all my angles and getting all the coverage I can, because once you actually import the object into a software, all these spots that you don't hit are just going to end up as blank space. I am going a little fast here scanning this room, and that is going to affect the final image quality of the scan. However, if you do give the LiDAR more time to feed itself the environment, the overall definition of the image is going to be a lot higher for the mesh object, but you can expect a larger file size that comes along with it. And then I'm just finishing up here trying to get the corners of the ceiling, and then I am finishing up the scan by pressing on the recording button on the bottom. And I'm going to want to press on the view scan option in the middle here, which is going to show me a overall rendering of the room I just scanned. Then once it's fully rendered, I'll press on the eye on the top right corner. This is then going to reveal a prompt that allows me to share the .obj file. I'm going to then email that file to my computer. Now, before I'm ready to leave the actual area, I'm going to go on the app and use the measuring tool to actually compare the measurements on the app to what I'm seeing in real life. Now, assuming if you have the correct conditions, you can have an accuracy of up to 3 millimeters or so. I'm getting around a margin of about half an inch, but this is going to be information that we need to keep for when we decide to scale up the objects in AutoCAD later on. So now that I have the .obj file uploaded onto my computer, I'm going to go ahead and open Blender, which is a free open source software that allows me to manipulate 3D objects in a space. Before we go ahead and do that, I'm going to need to add an extension that allows me to upload my files onto AutoCAD once I'm done with them. By looking up Blender AutoCAD Export add-on on Google, you can find a link to a download which allows you to add the extension to your Blender software. Scroll down to the Get Add-on option, which is going to allow you to drag and drop the item into your Blender software, or you can download it onto your disk itself. Just going to click OK here. Once that's done, you want to open a general file. But before we actually start working with it, we're going to double check that our AutoCAD extension was actually added to our Blender software by going to File, Export, and verifying that the AutoCAD option is indeed there. And then we're going to begin by deleting this default cube that's in the center of the plane. To do that, we'll hover over the cube and then left click until the item is highlighted yellow. Then we're going to right click, which is going to bring up a splash menu. We're going to scroll down to delete and then delete. To import our 3D mesh, we're going to want to go to File. I'm going to open a splash menu. Scroll down to Import. And then we're going to want to choose the option wavefront.obj. This is the file type that we exported from our Canvas app itself. And then you want to go ahead and locate the file within your computer. And then once you locate the file on your computer, you're going to see two files, one that is a .obj file as well as a .mtl file. You're going to want to select both of these and then import it into the Blender software. Doing so will load our LiDAR data onto the 3D plane here, as you can see. With that being loaded in, we can now toggle different viewpoints that allow us to see within the object. We can view it through an X-ray, or we can do as what I'm doing here and rendering it with its textures included. However, you will notice that it will appear as if the object is inversed. It is actually not. You can zoom in to the object where you can see the view that we had earlier on when we were loading it into the app itself. However, if we want to actually look at it from an external viewpoint, we cannot at this moment. This is where the next step comes in, where we will now remove the ceiling in order to get a top-down view within the room. We'll start by going to the axis in the top right corner to change our viewing axis. There are shortcuts you can take by pressing numbers on the number pad, with the front angle being number 1 and the top down angle being number 7 on the number pad. So we'll go ahead and change the angle to the front. Next we'll click on the object mode option, which is going to reveal an edit mode option. I'll click on that, which is going to reveal our wireframe. Next we're going to want to click on X-ray. This will allow us to make selections on objects that we cannot see directly. Then we'll go ahead and hover over the ceiling, to which we will click and drag to make a rectangle selection. Once our ceiling has been highlighted yellow, that means we have successfully selected it. Then we can go ahead and right click on the ceiling, which will reveal the slash menu once again. Scroll down to select delete vertices. This will then delete our ceiling. We can now hop back into object mode, as well as disabling our X-ray. Once everything is done correctly, we will now have an external view that allows us to see into the room that we scanned. Now we'll go to File, we'll scroll down to Export, and using the extension we added on earlier, we will export the file as an AutoCAD DXF file. From here we can name our file, as well as choose the destination to which it will be downloaded. We can then export the DXF and then load the file onto AutoCAD. Before we do that, let's go to File, then go to Save As, and then save our model as a .blend file so that we don't lose our progress later on. Once we have our model uploaded into AutoCAD, we can now use our model to create top-down floor plans. To start, I'm going to turn on ortho mode, and then I'm going to go to Layer Properties so that I can create a new layer for our objects. I'm going to name it Mesh, then I'm going to close my Layer Properties menu. I'll then select all the objects on the screen by either pressing Ctrl A or clicking and then dragging across the screen to select the objects. I'm going to choose my layer and I'm going to select Mesh, which is going to then move the objects into that layer. Next, I'll use the dimension tool to check the scale at which AutoCAD has decided to read the file. Here I'm snapping my dimensions to the corners of the wall, which I know the real life measurements to. Once I have this dimension, I will divide my desired value by this dimension to identify the scale at which I need to amplify the object. Once I've calculated this value, I will use Ctrl A to select my objects. In my command line, I will type scale. And then for my base point, I will use the corner that I started my dimension from. I will then type in the command line the value at which I calculated from my scale earlier. Doing so should yield results that match my real life dimensions, in this case 140 inches on the south wall. With our scale now set, we can now begin the floor plan drawings. To do so, we will first select our objects again, going to our layers, and then locking our mesh layer. This will prevent us from making adjustments to our mesh object while we are drawing over it. From here, you can trace your mesh object from the top down using the line tool. In this case, since it is a rectangular room, I will be using the rectangular tool and matching my corners. With the outline of the room done, you can also add door frames and other details along with it. Here I'm going to draw the actual objects within the room. Because we know the real life dimension of this table, we can also check the validity of the scale of this model by using it as a secondary benchmark. It seems that our measurement seems to be off by about half an inch, which, considering the conditions and the equipment we used, this is not an awful result. We can also observe that our object markups are related to a physical object within space, so it is possible to use the model for elevation data. Now let's just say you wanted to use the model that you created for applications outside of floor plan drawing in AutoCAD. Now let's say I want to visualize progress for the project stakeholders. I can do so by adding my model to a PowerPoint presentation. To do so, I will open up Blender again. This time around, I will export my file as a GLTF file. From here, I can go into the Insert tab on PowerPoint. Then I can go to 3D Models, this device, and then I can locate my file within my local files. Once you've located the file, click Insert. Once your model has loaded into a slide, you can change the viewing angle through the axis within PowerPoint itself. Similar to other 3D models within PowerPoint, you can also add animations to your 3D model by going to the Animations tab, clicking on your model, and then choosing the animation style. If a top-down viewing angle is not enough, you can remove walls in a similar fashion. Furthermore, you can create new angles using the pan and zoom option. That'll be the end of this demonstration, and I hope this was able to teach you something new.